I'm Joan Cartan Hansen. Welcome to this dialogue WebExtra. We're talking with John Grossenbacher, the director of the Idaho National Laboratory. An email question that came in asked about EBR2. What's the Idaho National Laboratory's opinion of the destruction of such an historical site that was an instrument in the beginnings of nuclear energy renaissance? Perhaps you could start by saying what EBR2 is and then explain where it's going.
Okay. Well, EBR2 stands for Experimental Breeder Reactor Number 2, and it was a sodium-cooled fast reactor, means it operates on fast neutrons. It was built at what was then called Argonne West. It evolved to demonstrate a closed fuel cycle for fast reactors. That is, a reactor that you could reprocess its fuel and then use it. And the facilities around EBR2 were designed to support it, and it operated for 30 years. It was an extraordinarily successful experiment. People sometimes forget that way back then, we thought that there was going to be such a demand for nuclear energy that we'd quickly run into shortages of uranium. So we had to figure out how breeders worked and how we could make more fissionable material than we use. Now, EBR2 is, our current plans are to take EBR2 down, not to preserve it, in part because EBR1, the first reactor that ever generated electricity, is a National Historic Monument and open to visitors. EBR2 is in a important piece of real estate next to some very significant operational facilities. So it would be very difficult to have a public access and museum next to that. And I think the successor activities we have planned for EBR2 will be very supportive of that important legacy. So no, don't plan to preserve it.
Okay, well, let's go to our callers. Larry in Cataldo. Larry.
Hello, yes, my name is Larry, and I was curious to know what information I could get about a public company called International Isotopes that's been doing work in Idaho for a long time. They do a lot of nuclear medicine stuff, and of late they have a technique of making fluorine gas out of nuclear waste. And I was wondering what information you guys had on that.
Well, I don't have any specific information about International Isotopes. I mean, I know of them. I know some of their people. I know some of the work they do. And I think that what you're referring to is when you enrich uranium, when you try to change the composition from what naturally occurs to something more useful, fluorine gas is used, and like the proposed centrifuge plant that Areva wants to build, the Eagle Rock enrichment facility. And I think what you're referring to is International Isotopes is interested in, okay, when you're done and you have this uranium fluoride, we can disposition that.
Okay.
So I think that's what they're working on.
Okay, thanks for your question, Larry.
Okay.
Brian in Garden City.
Yes, as we look at our current economy, we sort of look at that with trepidation. But as we look back at the development of, say, the internet, technologies and the innovation there, that had a big effect on the economy. Looking now at the possibilities for fusion, do you perceive any major opportunities, economic or technical or both, for new fusion technology?
Oh, wow. Yeah, well, no, thanks for that question, and I'm going to probably offend all my fusion colleagues. Fusion research, I mean, there's an enormous amount of fusion research that goes on around the world.
I'm going to stop you. Explain what fusion is. I just want to make sure we keep everybody up on the subject.
No, thank you, ma'am. In fission, we take a heavy atom like uranium and you cause it to split, and in the splitting process, energy
creates heat and energy.
Yeah. Right.
Okay.
With fusion, you take lighter atoms and you actually cause them to fuse together, and it requires enormous heat to do that. There are devices that have been built to investigate, and there's a project in Europe to build a large fusion device. One of the challenges is that the amount of energy that's required to cause that to happen, that fusing to happen, it takes an enormous amount of energy, takes very high temperatures, and materials can't withstand those conditions. So, how do you do it first? How do you create a fusion reaction that you can sustain, that you can actually keep feeding it?
Right.
And then how do you extract energy out from it in useful energy and have it be more than you put in? There are a lot of fusion scientists and fusion enthusiasts who see the future for fusion as very bright. I see it as it's important work. It's a very important scientific work. I think the engineering challenges to making it a practical energy source have to be acknowledged as enormous, and I think real success. I mean, a practical fusion device is just, it's out there somewhere, and I don't know how far out that is. And I don't think we can, certainly the country can't bet its energy infrastructure and future on that. So good scientific work, important, but
A ways away.
a ways away.
One of the things that in your presentation to legislators at the beginning of the session, you talked that the folks at the INL set a new world record for nuclear fuel performance.
Right.
What is that?
Well, what that talks about is we're developing the fuel for the type of reactor that we think will be used not to generate electricity, but to process heat for industrial processes. And what that replaces is today people burn natural gas to do it, primarily. So, the Dow Chemicals of the world and their petrochemical facilities, they need heat and steam. And where do they get it? In general, they use natural gas, which is bothersome to them because that's also the feedstock that they make things out of. So this is a reactor that operates at a much higher temperatures than the ones we use today. And the fuel performance was, how long can you leave this fuel in a reactor fissioning? Every time a uranium atom fissions, it breaks into parts and it tends to damage the material that holds it together, however it's structured. Some of the products of the fission are gases, and they can collect and bubble, and so there are limitations in fuel performance because it's got to maintain its integrity, physical integrity, and you have to be happy with its continued performance. And this particular fuel, the real manufacturing of it anywhere in the world, was more art than science. And what we've done with our people at the lab and some other labs and some folks in industry have collaborated with us to figure out how to do this, understanding how to do it from a scientific point of view so it's replicable, and then tested it. And so it performed longer and produced energy longer in a reactor than any fuel of its type has ever done. So we're pretty excited about that. It's great stuff.
Now, you first came on Dialogue just shortly after you came here. It's been a few years.
Right.
How has the INL changed in that time period?
Oh, well, we had collectively, with all our employees, a vision to create a world-leading institution, internationally recognized, primary mission nuclear energy, but important work, and a leader in national and homeland security, research, development, demonstration, technology deployment, and a lot of important clean energy work. And we set a goal for ourselves to be there by 2014, and I'd say we're well ahead of that in terms of the capabilities that have come to the lab, the work we do, both the type of work as well as the quality and the people we're attracting. So we've been on this path to a world-leading institution, and there's no question that we're making it. We're going to be there, and I think substantially before our goal of 2014. So we're pretty happy about that. I mean, so there's lots of new facilities. I can think of 4 new buildings in town.
In Idaho Falls?
Yeah, 4 out actually out on what we call the research and industrial complexes out on the desert, and more to come because we're getting the right people. They're doing impactful, extremely important research and work, and that brings the latest and greatest in scientific tools and instruments as well as facilities. So I think the future is extraordinarily bright, and the identity of the lab, I think, is what's changed.
Well, it was to a certain extent, it was always kind of a poor cousin to some of the fancier non-state named labs.
Those days are over, Joan. Those
Why?
days are over. Well, because of the work of the people there, and because we have people who have brought the right talent there, the right capabilities. They picked the right things to work on. Again, I like to think of the laboratory as a capability machine. So what capability do you want? Well, what are the hardest problems in the country? Which ones need to be solved? Which ones nobody else has a clue how to do it? And so let's get the people and take those tasks on. And if we pick the right tasks and the right capabilities, and we will flourish. And that's been the case. And it's a real tribute to the people at the lab. And the people that were there, before we created the INL, I mean, they deserve an enormous amount of credit for going through all the transition and change and seeing the future and supporting it. And I couldn't be prouder of them.
I'm afraid we've run out of time. Thank you for being here. I appreciate you joining us.
My pleasure.
And thank you for joining us for this Web Extra.